All right, let's dive right in. Today, we're tackling a huge topic for developers, the beautiful and sometimes maddening chaos of microservices. We're going to explore how to bring some serious order to that chaos using a powerful set of tools built specifically for this job, Spring Cloud.
So, you finally did it, right? You broke apart that massive, monolithic application into a whole bunch of small, independent microservices. But instead of this developer paradise you were promised, you're facing a brand new set of problems. How do you handle configurations for dozens of services at once? How do they even find each other to talk? And when a request fails, how on earth do you trace it through that complex web of calls? It can really feel like you just traded one giant problem for 100 tiny ones.
And this is exactly where Spring Cloud comes in. Think of it as the essential toolkit, the Swiss Army knife, for building and managing these distributed systems. It doesn't give you just one solution. It provides a whole suite of battle-tested tools that are designed to solve these very specific challenges. It's your map and compass for navigating the microservices maze. Okay, so here's our game plan. First, we're going to tackle that configuration chaos. Then, we'll figure out the communication puzzles between all our services. After that, we'll talk about how to guard the front door to our entire system. And finally, learn how to trace a request journey from start to finish. Let's do this. First up, let's talk about the absolute headache of managing configurations. You know, when you have one application, it's pretty simple. But when you have 50, yeah, it's a nightmare waiting to happen. I mean, think about it. Every single one of your services needs its own settings, database URLs, API keys, special feature flags. If you're managing these in separate files for each service, a simple change, like updating a password, suddenly means you have to hunt down, edit, and redeploy a whole bunch of different services. It's slow, it's inefficient, and it is extremely error-prone. The solution here is Spring Cloud Config. It's a really elegant idea. It gives you a centralized server to manage all of your configuration files in one single place. Your individual microservices then just act as clients, and they pull their specific configuration from the central server when they start up. And here's the best part. The config server usually pulls all its information from a Git repository. That means you automatically get version control, a complete history, and an audit trail for all your configurations. Even better, it supports dynamic refreshes, so you can change properties without having to restart your services. And, of course, it can encrypt sensitive stuff like passwords for that extra layer of security. Okay, so our services are all configured. Great. But now they need to actually find and talk to each other. In a dynamic environment where services are scaling up and down all the time, just hard-coding IP addresses and ports, yeah, that's just not going to work. This really brings us to two core problems that we have to solve. First, service discovery. How does my order service find the current network location of the payment service? And second, load balancing. If there are 5 instances of that payment service running, how do I spread my requests evenly among them so I don't overload just one? Well, Spring Cloud solves this with a beautiful 1-2 punch. First, you've got Eureka, which acts as a service registry. Think of it like a dynamic phone book for all your microservices. When a service starts up, it registers itself with Eureka. Then, when another service wants to talk to it, it just asks Eureka for the address. Simple. Then you have Ribbon, which is a client-side load balancer. It works hand-in-hand with Eureka to get a list of all available instances and then smartly distributes the outgoing requests. And to make the actual code for all this communication way cleaner, we can use something called a Feign client. This thing is awesome. Instead of manually constructing HTTP requests, which is messy, Feign is declarative. You just define an interface with some methods and annotations, and Feign handles all the complicated HTTP stuff under the hood, even integrating with Ribbon for load balancing. It turns complex network calls into clean, simple method calls in your code. Okay, so our services are configured, they can talk to each other, but what about the outside world? How do external clients, like a web browser or a mobile app, talk to them? Exposing every single microservice directly to the internet is a massive security and management nightmare just waiting to happen. And this is why we have the API gateway pattern. An API gateway is a single, unified entry point for all incoming requests. It's basically the bouncer at the front door. It handles all the critical stuff like routing requests to the correct internal service, authenticating users, enforcing rate limits, and logging traffic. This keeps all that complex logic out of your individual microservices, where it doesn't belong. Now, in the Spring Cloud ecosystem, you've really got 2 main options. There's Zuul, which was the original gateway. It's solid, but it's based on an older blocking architecture, which means it can get bogged down waiting for slow services. The modern and frankly better choice is Spring Cloud Gateway. It's built on a non-blocking, reactive foundation. This means it can handle a ton of requests at the same time without waiting around, making it way more performant and scalable. For any new project, this is the one you want to use.
All right, we've arrived at our final challenge. A user reports an error. The initial request hit your API gateway, then went to the user service, then the order service, which then called the inventory service. And somewhere in that chain, the request failed. How do you find out where and why? This is the classic distributed debugging problem.
The solution is distributed tracing. It's the process of instrumenting your code so you can follow a single request from the moment it enters your system all the way to the end, tracking every single hop it makes between services along the way.
Spring Cloud gives us two amazing tools that work together for this: Sleuth and Zipkin. Think of Spring Cloud Sleuth as the instrumentation library. You just add it as a dependency, and it automatically injects unique tracking IDs into the headers of every request. Then you have Zipkin, which is a separate server and UI. It collects all this trace data from Sleuth and gives you a visual dashboard to see the entire journey of a request. So here's how it works. When a request first hits your system, Sleuth gives it a unique trace ID that sticks with it for its entire lifecycle. Then, each individual step, like a call to another service, creates its own little span. Sleuth makes sure these trace and span IDs are passed along in the headers of every call. Finally, Zipkin collects all these spans and reconstructs the full timeline, showing you exactly how long each step took and, most importantly, where any errors happened. It's like having a GPS for your requests.
Phew! So we've covered a lot of ground, right? We've really moved from a place of chaos to one of clarity. Let's just quickly summarize the essential toolkit Spring Cloud gives us for building robust microservices. See, this isn't just a random collection of tools. Each one of these addresses a fundamental challenge of distributed systems. You centralize configuration with config, you enable dynamic communication with Eureka and Ribbon, you simplify the actual code with Feign, you protect your system with Gateway, and you get that critical visibility with Sleuth and Zipkin. Together, they create a cohesive, manageable, and truly resilient architecture. Ultimately, Spring Cloud really embodies the best practices for microservice development that were learned over years by companies like Netflix. It provides you with these ready-made solutions to incredibly complex problems, which lets you focus on writing the business logic that actually matters, instead of constantly reinventing the infrastructure wheel. So we've seen how Spring Cloud provides both the map and the toolkit to navigate that tricky microservices maze. It transforms what can be a really overwhelming architectural challenge into a manageable and powerful way of building applications. The only question left is, what are you going to build with it? Thanks for watching.